Hi, everyone. Thank you for joining us today. My name is Damon Reed. I'm with Pro Refrigeration. I'm going to be off camera and leading a discussion today. We're going to be reviewing brewery expansions and not to forget about the cooling system. Joining me today, I have got a great group of brewing veterans that have all been tasked with taking their breweries to the next level. Focused on the cooling system, our conversation is going to cover multiple aspects of the brewing process. The structure of our conversation today, we're going to have a 45-minute panel discussion and then follow that with a 15-minute Q&A session. If you can, as an attendee, post your questions throughout the event, and towards the end, our moderator will queue those questions up for each of us, and we will address them. So again, my name's Damon with Pro Refrigeration. I've been with the company since about 2005. The 10 years prior to that, I spent my life working as a service technician and in sales for a refrigeration contractor. Right now, what I do for Pro Refrigeration is I lead the technical support, R&D, field services, and applications engineering teams. I've worked with hundreds of breweries on system design, and I also do presentations with the Master Brewers Association, technical meetings, including the engineering and utilities course.
My name is Jason Knox. I work at Trogs Brewing Company. I've been here since 2007 and have overseen numerous expansions related to building expansions, brewing expansions, packaging expansions, chilling expansions, all the good stuff. Before that, I spent a great deal of my former life as an industrial electrician. Know a lot about servo motion, PLCs, programming, and that's one of the main reasons that I got brought on board at Trogs. The brewing world was getting a lot more automated and sophisticated, and without that training behind you, it's kind of difficult for the owners to keep progressing forward. So I've been here. I've seen this place go from 13,000 barrels to about 108,000, and willing to answer any questions you have.
Great. Thanks for joining us, Jason.
You're welcome.
With that, I'm going to introduce Mr.
Hey,
Glenn Lewis.
Jumping right in.
Of course.
– 2011, we started with 3 40-barrel fermenters, and we're rapidly approaching 20,000 barrels in annual production, and I've sort of been along for the ride that whole time. I actually started at sales here, but as we got more and more equipment and it got more sophisticated and started to just wear out and need, repair, replacement, upgrade, expansion, sort of gradually at first moved into that more mechanical role, and I've been doing that full time since 2015. So we're the smallest brewery on the panel today, and we're sort of a 1.5 person department here. So I sort of simultaneously oversee everything in terms of the physical plant, but also get my hands dirty every day and install cool fit piping, like piping, probably more often than I'd like. But.
Thanks a lot for joining us, Glenn. I'm glad you were able to find the time to help us out here.
Hi, my name is Garrett O'Malley. I'm the Director of Maintenance at Treehouse Brewing Company in Charlton, Massachusetts. I've been with Treehouse since 2017, which was the year that we moved to our new facility here in Charlton, about 30 miles away from Munson, Massachusetts. We were a much smaller brewery at that time, in single digits, around 10,000 barrels a year. We moved to Charlton in 2017, and since then have now increased to a little over 50,000 barrels a year and rapidly growing. My role here stemmed from preventative maintenance. When we moved to the new facility with a much higher level of automation and control over the brew house, the cold block, packaging area, and the building in itself. That is more or less how I started with Treehouse. That my role has now grown more into a project management and in general contracting role. We manage many of our construction and expansion projects in-house, and that's where my department comes in. We spend a lot of time coordinating and communicating with vendors, engineers, architects, designers, fire protection engineers, and so on and so forth to to make sure that we're getting the best quality product that we can get, and that it meets our goals and our needs for the future. So thanks for having me today.
Thanks. I just want to let everybody know that's joined us. The group of the four of us, Jason, Garrett, and Glenn. We're all really hands-on, nuts and bolts kind of guys with everything, and we've all worked through multiple different projects and all felt a little bit of each other's pain as we've ran through stuff. Whether it be during the actual construction and commissioning of systems, or whether it be on the after side, the support and making sure everything's good. So really appreciate everybody, and this is a great team. So with that, I'm going to open us up with our first question. You guys have all been through some really large expansions, even some smaller expansions. Considering your cooling systems, in hindsight, what did you guys learn that could have made your lives easier had you known? Kind of that wish I knew what I didn't know now kind of thing. Jason, why don't you lead us off with that one?
Yeah, I think one of the biggest things, well, once you get the sizing and all the technical stuff out of the way, then you really need to know your surroundings. We ran into some rigging issues, like actually physically being able to put the chilling system where we actually wanted it to be and hook it all up. We ran into building power lines, so we had a lot of different entities trying to help us out. So figure out where that's going to go. Planning for the future is definitely a significant one. Somehow, if you could make your chillers redundant, if you have more than one, so potentially having like one separate skid full of your glycol and then 2 units to keep that chilled, and a bunch of valve work and matrix to be able to, if one of the chillers goes down, that you can get the other one running to keep your glycol cold. One of the big things that we learned over time is a first in, last out configuration with your tanks. That took quite a while for that concept to sink into me. Now it seems pretty commonplace, but when you're setting your tanks up for that and your pipe work, you really need to understand how you're going to get glycol from A to B and B to C and back to D. So, and the other thing that we did here is we went with a stainless pipe for everything for our glycol system. So we had to do a bunch of research on insulation to figure out, because stainless isn't a very good conductor of heat or cold. So we had to figure out a way to keep that as cold as possible. So yeah, that's all I got.
Yeah, no, that's great. That's great. That definitely, talking about having redundancy built into a system, I can definitely appreciate how each one of you in your roles, how something like that could be so critical for sure. Garrett, why don't you give us a little take on your experience there? Hey, Garrett, I think we lost your audio. Glenn, I'm going to jump over to you.
Can you hear me?
We can. Yep.
Yeah, I would say not to keep harping on the size that we are, but it just is what it is. But we started with a 10 horsepower chiller, and when we outgrew, it took us a long time to outgrow that. That was enough for the first 2 or 3 years of production. And when we first never need another chiller after that. And less than 18 months after that, getting that chiller commissioned, we were looking at putting in an expansion to double that to 80 horsepower again. So obviously there's some cost concerns, pro and con on both sides. Some of the things you don't consider now, we had already run the electrical for the original 40 horsepower chiller. Then when we had to go back and add an expansion module, we had to run that electrical again. We had to have another concrete pad. We had to go back to the town for permitting like that. We had to have more bollards installed. So I think that, in hindsight, I would have probably, maybe not ultimately bitten the bullet and done it, but at least taken a good hard look at what size that chiller was going to be, what our expansion plans were, talk to sales and marketing. What's the forecasting look like? Do we maybe want to just jump right up to that next size? If we think we need 40, maybe we go 60, and just save yourself some trouble in the long run, even though it's a little more expensive up front. And then The other thing would just be with the piping system, give yourself an in and out everywhere. We put kind of what seems like extraneous ball valves all over the place. And I know from an engineering standpoint, you don't like to spec out extra things, but if you're in a tight space, especially, we haven't built a new brewery yet. We're just kind of growing in our existing space. We're always doing stuff that you'd never think you'd wind up ultimately doing, and having that isolation to put a ball valve here and drain a single section without pulling the whole header out or something like that makes a big difference in minimizing downtime when you do ultimately need to add some new equipment or sort of replumb or redesign some things.
Yeah, that makes good sense. Yeah, having extra ball valves and things to be able to tie into, I could see that being a huge asset. What about, so when you guys went through and when you were planning your expansion, what types of available supplier resource did you guys find most useful? And I mean, from the all aspects of suppliers, chiller suppliers, brew house suppliers, the tank manufacturers, all the other components that would go in, boilers, for example. If there was load calculation tools, piping recommendations, that type of stuff. How did you use those resources, and which did you find of value? Garrett, if you'd like to take that one on for us.
Yeah, sure. We tried to start early and keep on it often. So the second you determine that you're going to be expanding, or you feel like you might be a little bit more constrained than you want to be, you need a little bit more flexibility, maybe you need more space, you want to contact your vendors and your suppliers immediately, because even if you're not going to end up buying anything from them, they're going to be a wealth of information. They're going to give you different ideas, and sometimes you're going to glean things from them that you didn't even know were possible, or you didn't even consider in the first place. So I like to take the approach of as many cooks in the kitchen early on, and then you wean that down until you have your more or less your substantial team to expand. We've used dozens, maybe hundreds of resources from different engineering firms, civil, mechanical, private engineering firms, architectural firms. Some of the suppliers that we've used, Pro Refrigeration is generally very helpful with load calculations, helping you form a snapshot of your coal block or of your brewery as a whole, and what your cool load really might be, or your heating load for that matter. And make sure that you're not undersizing, and just as important, make sure you're not oversizing. You can run into a lot of issues if your approach is, let's just make it as big as humanly possible, and grow into it. Sometimes, for pipe size for that matter, you could end up with discrepancies throughout your system. So you really want to lean on those folks as much as you can, ask as many questions as you can, and make sure that your resources understand your key guidelines and your key goals and what you're trying to accomplish in your brewery, because every single brewery that I've ever been into is a little bit different, sometimes a lot different, and there's no cookie cutter plan, and there's nothing that you can't do. It just takes some massaging and some flexibility.
Oh, that's great. That's great. Well, Jason, how about yourself?
So, I mean, I do not have a degree in engineering. I like to tell people I have a PhD in common sense. Unfortunately, load calculations and stuff are a bit beyond me. Our owner loves to play with numbers and stuff like that, and I've had the distinct advantage of having new equipment pretty much since 2011. So we have dealt with Braucon, who is our brew house manufacturer, and I think they have 15 or 20 German brewmasters on staff that completely understand this stuff, and they could lend their resources. Zeman was another manufacturer that we dealt with for our tanks, and they also could lend those resources for pipe sizing, load calculations, pump curves, the whole 9 yards. And on top of that, we are in South Central Pennsylvania. We're in a manufacturing mecca around us. So any type of material or equipment that you want, we can get pretty quickly, given our geographic location. So there are tons of engineers and external contractors that can help you with those things. And those are some of the things that I think people overlook is, so maybe you have a plumber or a welding contractor that you're used to dealing with. Well, those people have been in many other plants than what I have. So we can lean on their resources and their experiences in the School of Hard Knocks to figure things out.
Yeah, that's very, very true. Yeah, that makes good sense. Did you guys considering like your utilities and your placement of systems, how big of a driver was that? Piping locations, electrical, maybe some foundation work. When you were looking at placement of your chilling equipment, how kind of maybe share with us any of your unique situations that you might have encountered. Glenn, given how we got this photo of your system up, why don't you take off with this one?
Yeah, we were in a, or still are in a relatively unique situation where we're in an industrial park. We still share our sort of compound and loading dock area with one other business, so we have some restrictions on where we can put stuff. We have a lot of ingress and egress of trucks and things like that, obviously. So we were working on trying to get a much larger chiller put into a smaller package to try to make it fit, not in the existing footprint per se, but at least in the existing width of our small 10 horsepower chiller. And ultimately that wound up not really being practical, but we're able to find another location within our sort of back parking area. But it did require a lot of more utilities. I already sort of mentioned before, like having to do electrical, heavy duty 460 volt service run out to the new chiller, concrete pad, a bollard installed, and we were up and running when we switched to this chiller. So we had to take our existing GLYCOL loop and cut into it, splice into it, and run all new piping all the way back from the original location of the chiller back to the new location. So
I think we lost you a little bit there, Glenn.
Can you hear me okay?
Yep, you're back.
Oh, okay.
No, we lost you, but
we lost
Garrett?
Glenn. Yeah, I'll jump in here. I couldn't quite pick up the tail end, so I might be reiterating what Glenn said. But I would, as far as the projects that we get into, we're in a bit of a different situation. We're in a much more rural area with a lot more free space around us. However, chiller specifically, it's pretty common for probably everyone listening that's designing or trying to grow their brewery or production facility of any kind, is you generally want to try to keep that GLYCOL chiller in somewhere where no one ever sees, which is an advantage from aesthetic standpoints and for space saving standpoints, but you're trying to tuck it out of the way and out of sight, out of mind, if you will. So when you do that, the biggest thing for us, and the biggest thing that I always fall back on, is as-built drawings from construction projects and other expansion projects. If you don't have those available to you because you might not own the property that you're on, or you weren't there when it was built, maybe it's really old. There are tons of services out there, generally not as advertised as well as say a vendor of refrigeration equipment, but there are engineering services out there and examination services out there that will help you evaluate your property and maybe do some test pits, some examination of your foundation, find out where footings are. If you plan on leaving your building, what the best either above grade or below grade wall to do so would be. But having as-built drawings and having an idea of what your property actually entails will help you out immensely in the beginning. Otherwise, you're going to find yourself in a situation where you're trying to put a GLYCOL chiller in a certain place because it looks like the most obvious location to put it, and everyone around you agrees, but no one quite knows what's going on 6 feet below the earth there. And when you go to bring that 100 amp service up underneath the ground there, you're going to be dead in the water. And if your house or your cold block was reliant on that chiller, you're in for a much longer shutdown than you planned for. And as we know, schedule conflicts like that can really debilitate an operation that your main goal is to be making beer every day of the week and selling beer every day of the week. So you don't want to find yourself in a position where you didn't know what you were getting into before you got into it.
Yeah, definitely. Jason, you had kind of a unique, kind of on your front end of where things were placed. Why don't you tell us a little bit about kind of how that evolved, that pad?
Yeah, so we had an old railroad spur, which if anything's going to be compact and sturdy, I'm pretty sure if trains can go over it, glycol chillers can sit on it. So we sat our first one on the tracks before we got wise to the fact that, man, maybe we should just pour concrete and be done with it. But we knew when we did the first chiller, we had our outdoor switch gear. We came off of it with 4-inch conduits, and we ran them over. And I was like, well, you know, if we're already up in the sky, we're already hanging unistrut, we're already doing channel, we're doing all these other things, why don't we just run the second set of conduit and get it 90% of the way there, and then we'll tie it in at the second point. So some of that I know comes back to expansion, rigging, power lines, all those kind of things you really have to pay attention to. The one thing that I wish we would have done a little bit differently with our system was, I think Glenn touched on it a little bit, that draining the glycol out, if you have to drain the glycol out for some reason to be able to add a tap into the line, or if you have a leaky tank or something and you can't isolate it, I think that's a huge deal. An ability to easily test your freeze concentration from your glycol would be something I would advise. Put a sample port somewhere so you can do it inside of the building, not outside. And also to be able to add water to adjust your freeze concentration or pump more glycol back into your system. I think those are all things that, you know, could be classified as a utility that would make your life a lot easier in the long run.
Yeah, good point. That's I know I often myself just stay focused on just the piece of equipment outside. I don't realize sometimes that putting in some of those things inside the facility saves you from having to be out in the weather and getting on the equipment. That's a good point.
Yeah, it's always fun getting a sample out of your 2,500 gallon glycol reservoir in the middle of Pennsylvania winters.
Just don't fall in.
The only time
Sometimes it's warmer in the glycol, though.
Yeah, that's right. That's right. How's about considering the glycol piping? When you guys were working with your glycol piping, what were the most useful resources that you kind of wanted to pull together as you started to plan your glycol piping? And in particular, I'm thinking of things like your tank specifications, pump specifications, and any kind of pipe sizing tools that you had available to you. Glenn, now that we got you here,
yeah, hopefully I'll stick around. I apologize, I'm
one.
getting a little bit of a bad connection, but yeah, that's sort of what we do the most of.
Understandable.
Here. We do all of our piping ourselves, and one of the biggest things is, as a smaller brewery, and as I mentioned before, we haven't. So we're not building from scratch. We started with 3 tanks from one manufacturer. Our first expansion, we added a couple tanks from a different manufacturer, and the ports were configured differently, and the flow rates and specifications were different. And trying to sort of get all that in one place, and not to drift back to the previous topic too much, but if you're getting assistance from your suppliers, a lot of times the information they're going to come back to you with is only as good as the data that you're able to give them. So you do need to sort of gather some of this on your own, know what your flow rates need to be, know what the tanks manufacturers are calling for, and understand if you're like us and you've sort of grown piecemeal over the years, that not every tank is created equal. They might just be different sizes, but they also could be different inlets and outlets, different.
Did he reach the
Promising
end of
you
the line
maybe
again?
based on.
We might have. There he is. Okay.
I'll jump in, Damon. I can jump
take
in.
over. That was going good.
No, yeah, we're ready to take over. I could kind of between similarities. We use a lot of George Fisher Cool Fit as well. But one thing with coming from my background, I saw many different types of piping systems that were transporting far more hazardous or far more aggressive material than glycol. And one of the first things that I learned when I came into the brewing industry was that no one really has a foolproof solution yet. And generally some of the best references that I've had are actually other brewery technicians and engineers, because we're the ones who've tried it. There's no end to the types of piping systems, insulation systems that you can put on for glycol. So learning what you're comfortable working with and learning what your plant can accept is really the first step. Beyond that, I'd say that working with your chiller rep or working with the piping manufacturer alongside other manufacturers is going to be a huge help too, because they know their product best. But as Jason said before he got cut off, they're only as useful as the information that you give them. So this is kind of twofold, because I think our next slide, Damon, sorry for jumping ahead, but I think our next slide really talks about technology. And if you have the ability to really have an understanding of what your cold block is doing and what your brew house is doing at a certain time, you're going to be able to narrow down your overall load and the overall demand for cooling in your plant. So whether that's taking periodic numbers, maybe on the hour, every hour for a week, or every 4 hours, you name it, however strict you want to be, or however much data you want to gather to do that. Likewise, if you have a data collection system, or if you're running any of your equipment off of a PLC, sometimes you can trend data and create that electronically instead of doing it manually. But there's no limitations to the amount of data you can gather, as long as you have the willpower to go out and read those temperatures, read those pressures, and record them in a concise and legible format, so you can give that information to the engineers and the vendors that you're working with and get the best possible recommendations.
Yeah, most definitely. Jason, what about with your experiences when you guys were doing your piping loop? How'd that kind of come into play for you guys?
So, the same as what Garrett and Glenn were saying, we rely on our tank manufacturers to say, hey, we built a tank. This is what we require. This is, what you need to crash. These are how many zones you're going to have. This is your volume of glycol. This is the pressure that it can take, and all those fun things. And we've had really good success. We've used JV Northwest. We've used Sprinkman, not the name drop. Zeman is one of our trusted manufacturers for all of our outdoor tanks, and their things are built rock solid, and they have really easy specifications that we have to do. We also worked with Pro Refrigeration quite a bit, since we were 95% sure we were buying our glycol chiller from them. We also asked their input and used their engineering staff to help us out on that also. And like I said before, where we're in a manufacturing mecca, and we have access to pump manufacturers, pump suppliers, all kinds of different engineers, food and beverage suppliers. There's all kinds of manufacturing plants around us and quite frankly, they love to help us out when we call the Hershey company down the road, the place that makes Hershey Kisses, and ask them about parts for their filler, and they're willing to talk to us because we make beer and we're friendly to them. So yeah. sometimes those people, like Glenn was saying, sometimes that's the easiest thing to do.
Yeah, definitely. I think kind of a good message I'm hearing kind of throughout is it's all about building that team of people that you're going to work with to get things going. I think Garrett, you mentioned that. So
yeah, you can't do it alone.
Trusted vendors, trusted suppliers. It's all one and the same, and it's amazing. Some people that you talk to, just a salesman that might be selling you the glycol that you're buying might say, oh, I have a company down the road that is doing something similar to what you're doing. Do you want to hook up and meet up with this person, and you guys can share some ideas and things like that? And it's always great to have multiple heads on a problem.
Definitely. How did you guys, when you were working, adding in your system, were you able to add in any new technology features that help make your life a little bit easier? And I'm talking about things like remote monitoring. Garrett, you had mentioned the historical tracking capabilities, maybe even some alert notifications.
Yeah, being able to monitor it without, like we said when we were talking about site availability and placing and building out your chiller, being able to, when we put a piece of equipment, again, out of sight, out of mind, it's nice to be able to, not nice, it's almost vital to be able to monitor the health of the system and the operation of the system remotely. If it's not a place that people are walking by constantly, I mean, Your brew house probably has eyes on it, you know, every waking minute of the day when you're in the building. Your chiller, probably not so much. So anytime you have that opportunity to add, whether it be remote monitoring or even if it's just an alert notification, nowadays that type of technology generally runs pretty cheap with cell phones and Wi-Fi technology being the way it is. So I would highly suggest you don't cut corners in that area, because again, it's in almost all breweries that I've seen that are smaller than us or relatively the same size as us, don't generally carry redundancy in this department. And if you don't have redundancy in this department, you're dead in the water the second your chiller goes down. So take those opportunities every chance you get. And even if that means, you know, spending a couple extra bucks here and there to make sure you have connectivity at your chiller, or maybe it's running an Ethernet cable to your chiller, I highly suggest you do so. It can be an invaluable tool.
Oh, that's great. Glenn, we just got your system online not too long ago. That we've already found some uses.
We absolutely
for that,
have, yeah. And that was sort of going back to what I mentioned, one of the early slides too, was that was one of those things, you know, we had power run out to the chiller, to the pad where we were putting it, and went back later after the fact, just, you know, sort of poor planning on my part, and ran the Cat 5 cable all the way out separately. Obviously, that would have been a lot easier to do when we were running power, have the electrician pull that at the same time. So just sort of looking at the importance of this stuff, big picture, and doing it when it makes the most sense. And don't wait to do it. We had, as Damon alluded to, we had a couple incidences over the years, one of which I always like telling the story. We had a totally unrelated to Kane Brewing. It happened in the middle of the night when we were closed, but a drunk driver hit a utility pole a couple blocks over from us. And we lost a phase on our 3-phase power. And for those of you who don't know that, if you've got a 3-phase motor running, when it loses a phase, it'll keep running. And there may be some overload protection or something that trips, but circumstances aren't ideal or there's no phase protection, that motor can burn itself out. And that's exactly what happened. So we lost our process pump, and at a glance, the chiller appeared to be working. The refrigeration portion of the unit was still running, but there was no glycol being pumped through the system. And that's the kind of thing that we would have, you know, gotten an email alert about, or some sort of other. It happened over the weekend when nobody was here, and we came in Monday morning and found, you know, our chiller wasn't working. And luckily at that time, you know, we were able to sort of rig up. I think I sent Damon a picture. I don't know if he chose to share it, but
I did. I did get
we
that
rigged
picture.
up. We got our. I think Jason was talking about having a team effort and having your trusted vendors, and we had our refrigeration tech here, our local plumber rigged up some flanges real quick, and we had a 5-horsepower cart pump that we used for the cellar, pushing our glycol through our entire plant for about 2 days until we got a new pump in and everything. So, but that's exactly the kind of stuff we might have had a day more heads up towards getting that fixed and minimizing that downtime if we'd had that remote monitoring. So I would say, obviously, most of the machines now, a lot of the bigger machines come with that capability. Just, you know, don't drag your feet. It's worth it. Just get it hooked up when you get the chiller installed, get everything set up, get those email alerts. You might get them in the middle of the night when you don't want them, but it's still better than.
I was going to add the disclaimer. It's not great getting an email at 2 o'clock,
Right,
2 a.m. saying that the tank is low, but it's better than the alternative.
And I know some places have bigger breweries sometimes too. You may have a maintenance guy who's there 24 hours if you're in production, and maybe at least it's but still always better to know than to get a pretty bad surprise when you come in on a Monday morning or something. So.
Yeah, absolutely. Jason, you guys incorporate quite a bit of technologies in your facilities as well.
Yeah, well, I mean, with the chillers, just speaking from the chillers, yeah, remote monitoring, we don't really change anything. It's more for the problems, but like Glenn was saying, yeah, fortunately and unfortunately, I do have technicians here pretty much 24/7. We have a 48-hour law over the weekend, but we have brewers in-house 24/6.5. There's only an 8-hour window where we don't have someone here from the lab or from the cellar that is paying attention to temperature. So we know if the cold liquor tank starts rising in temperature, or if certain fermenters are not going down as fast as they should be, then we know we have a problem, and that's when we start making phone calls and things like that. So spoiled, yes, to have technicians here, but I'd rather get an email alert from a chiller than have to write a performance review.
Yeah, I'll grab onto that too, because having the tech on site is great, but if the tech doesn't know that it's gone down, you might be maybe 3, 4, 6 hours, maybe even 12 hours in between rounds or shifts where they would even examine this equipment. You can't beat knowing about it right away, because especially if you have sensitive beer in a tank that can't go that long without having cooling. You don't want to be messing with those fermentation profiles. So be on top of it and keep it. It really needs to be thought of as front and center even though we're sticking these things and we're sticking these machines in places that we don't necessarily see them all the time.
Well, like I mentioned, in our situation,
yeah, I agree. Go ahead.
I was just going to piggyback on what Garrett's saying. In our situation, the outward appearance of the chiller was that everything was fine. The refrigeration circuits were running and keeping the reservoir cold. There was just nothing being pumped through the piping, and it took a long time. Because it happened over the weekend, by the time we came in, we saw we weren't maintaining tank temperatures and stuff. But to Garrett's point, even if someone had been there, it might have taken hours and hours to realize that something was wrong.
Yeah, most definitely. Sounds like new technologies have impacted us all. How's about this is great with we've talked about this a little bit kind of throughout the discussion, but what kind of things did your initial chiller have that helped keep your existing production goals met? And as I was rereading this slide, what also comes to mind is even what kind of things did it not have that you wish it would have had? For example, like expansion fittings, maybe valves installed on those fittings before the tank was full, that kind of stuff. Just would have helped make that transition a little easier. Garrett?
Yeah, sure. Well, right off the bat, Damon, I would say if you're using a central reservoir, which specific to our system we have 2 chillers, 1 reservoir. If once you're out of ports on that reservoir, you're done with that reservoir, unless you want to shut the entire thing down and drill new holes, apply new fittings, but that's going to require some substantial downtime. So keeping in mind what your facility has potential for growth, and knowing what is available to you to grow with the current chiller. We were in a situation when we brought in our new chiller that we didn't have a place to tie in the existing system when we were running new piping. So we had to build new fittings. We had to shut down the system for a couple hours, install them, and then reconnect the old chiller to the new fitting. So it can be a song and dance to get around this, and you can't plan ahead enough. But as far as maintaining your equipment once it's running, again, the periodic rounds and monitoring it is as frequently as reasonable, I would say. Not really a piece of equipment you want to post a guy at 24/7 and watch gauges. Yeah. It doesn't require it either. But having the ability to monitor every attribute of that machine is going to be vital. Some on less frequent occasions, but just making sure that it's operating as if it was brand new. There's not generally, in my experience, when troubleshooting refrigeration equipment or HVAC equipment in general, every single scenario is a little bit different, and there's no cookie cutter answer. You're always troubleshooting from a blank slate, and you kind of need to take it step by step. So it's very methodical, and it's very foreign to a lot of people, especially in the brewing industry, because we're so focused on a different art and a different science that we tend to leave this reverse art and reverse science behind. So learning as much as you can about the heat transfer in general and reaching out to people like Pro Refrigeration. I mean, Damon and I, like you said at the beginning, same as Jason and Glenn, we work very closely when we're troubleshooting these types of things, and it's a huge resource to have someone that is narrowly focused in the refrigeration world to help you through those problems. Because in our background and in the brewing industry, we're generally thinking about 9 or 10 different things at once to make sure that the whole product comes together as one.
No, that's great. I appreciate that. Glenn, how about yourself? When you guys tied into the system, how did that?
Yeah, well, we
how'd that
kind
go
of did
for
that
you?
two different ways. Similar to what I think Garrett was describing is when we went from our original chiller to the new chiller, because it moved locations, we did have to run all new piping, and we had no real way to tie in. So we had to actually cut and splice, minimize the downtime there. We were able to do that in a few hours, fortunately. But also, again, more recently, when we added the expansion module, we had the expansion plugs on our original reservoir. Foolishly, I did not remove those plugs and put ball valves in when we filled the reservoir up, and we got lucky in that sense. It's only a 550 gallon reservoir, so I was able actually to pump the reservoir contents out into a tote, pull the plugs out, replace them with ball valves, and fill it back up in like under 2 hours. But I still had to shut the system down for a little while. I had to pick the right time to do it when there was less beer, in critical, in a critical phase in terms of temperature control. So just little things like that you're, especially if you're a smaller brewery, you're unloading, rigging some of these things yourself, and you're excited. Hey, our new chiller's here. I can't wait to get it up and running. Take a look around, survey your surroundings, spend an extra $100 on ball valves and take the time to pull those plugs out and put ball valves in when the reservoir is empty the first time. Don't go back and do stuff like that. And that was just, like I said, too, at the beginning, give yourself an in and give yourself an out. Now when I do things, if I put a new loop in somewhere, instead of putting a 90 in, I might put a T in and put an extra ball valve in there just in case. And, minimal extra expense at that point. But we're at the point where you get to and any brewery, small or large, but you're always sort of at a point, but especially as you get bigger, shutdown is the biggest thing. It's always cheaper to spend a little money on an extra ball valve than it is to lose a tank of beer or not be able to be in production for a day or something like that. So keep that in mind, especially as you grow.
Yeah.
That cost of lost product or anything like that, or even just lost production where you're not losing a batch, but you're losing it in the sense that you're not brewing. That stuff adds up quick, and a few extra ball valves are nothing in comparison to that.
Yeah, that's great. Great feedback there. Did you guys, I think some people, as they're getting systems up and running, might not be aware that, they can utilize some field services for like factory commissioning of the system and stuff. I know, Jason, I'm going to have you field this, just knowing that we had worked together on some field commissioning. How did having people out there for the field commissioning of the system, how did that help kind of relieve some pressure from you during your expansion?
Well, I think it's imperative that you have on any equipment that you have the machine manufacturer, the OEM, show up on site to be able to make sure that everything is copacetic and your pressures are good, your ratings are good, your glycol temperatures are good, your pressures on your refrigeration is good, and go to town. Again, I'll circle back around to the teams that you create around you. I'm only as good as the people around me. I don't need to know all the answers. I just need to be able to find the answers and give that to the right people. So it's absolutely critical to create this network of people. I could probably do 90% of my job from my cell phone wherever I'm at in this world. It's just answering questions and helping people out. So the one thing that we did here is, as we segued into our second system, we actually brought Pro Refrigeration into our facility, into our conference room, to sit down with our 5 technicians and with a subcontractor that we wanted to be able to be our certified contractor for our Pro Refrigeration equipment. So we brought in a company. Their name's HB McClure. They're based in our area. They have a dozen refrigeration techs, and I think we had 6 or 8 guys from that team, along with their service manager, sitting in on that training. And Damon, what'd we spend, 8-10 hours, something like that?
Something like that. Yeah. That doesn't include the time at the restaurant. You kept us well fed.
Yeah. So that was a big deal, because now I'm not relying on calling Washington State or North Carolina and then trying to use my time and my resources to take care of that. So now I can call my trusted vendors who are very, very familiar with our building and bring them in at the drop of a hat, and they know much more than I ever am willing to learn about this system. So
that's great. That's
Good
great.
point.
Garrett, How about yourself?
Similar. I mean, we're more or less in a very similar situation. We have a couple mechanical contractors around here that we lean on a lot in central western Massachusetts, and we encourage them to learn as much as possible from the OEM, whether it's for the piping system, instrumentation, or the chiller itself, a boiler itself, because like Jason said, you can't have too many experts on a machine like this. It could be the difference between 6 hours of downtime and 45 minutes of downtime, because I can pick up my phone and call Ronnie, and Ronnie's already fixed this problem 3 times. Doesn't work for our brewery, doesn't work for Pro Refrigeration, but he's a chiller tech. He knows what he's doing around these types of machines, and we can reach out to these experts very quickly and have a problem that doesn't really need to be a problem resolved really, really quickly. So don't be afraid to reach out and go that extra mile with someone. Spend a little bit extra time with those people that are basically going to keep you alive, because this is a lifeline for you. So don't skimp on that regard.
No, that's great. That's great. Hey, with that being said, we have reached our Q&A period. So I'm going to go ahead and we're going to take about a 10 to 15 minute window here. And if there was any questions that any of the attendees wanted to get posted, go ahead and post those questions now. And in the meantime, we'll start fielding some of the questions we have. This is a question.
So Damon, are you going to read this question off? I'm sorry, I didn't mean to cut you off.
I think so, yeah. I'll read it off, and then we'll kind of see who wants to field that one. So this question's from Matt, and for planning purposes and living in warm climate, concerned with the amount of heat coming off the indoor unit. For those that have these or have experience with, are outdoor units preferred in hotter climates, or some sort of vent to redirect heat outside? Do you guys mind if I field that one?
It probably makes more sense, Damon. I'll ask you that question too.
Right on. So, Matt, one thing to consider is any of the heat that's being removed from the brewery is going to end up needing to be discharged somewhere. So if you're in a situation where you have your system indoors, then venting that discharge air adequately, and not only venting it to get rid of it, but also fresh air to make it up, is very concerned. That's something you should really be taking a look at for your planning purposes. With a hotter climate, we have systems, and I've seen systems in very warm ambience, southern Mexico, Arizona, for example, and those systems they should be designed and want to live outside. Mm-hmm. The nature of the beast with refrigeration. As your ambient temperature increases, that puts a little added stresses on your systems. So hopefully, your manufacturer should have already kind of planned for that with you and made some adjustments to the system to be able to handle that. But I guess from my own personal experience, I would say the system should live outside so that you don't have to worry about dealing with inlet air, discharge air. Otherwise, you do need to think about how you're venting and bringing in makeup air for the system. If it's air cooled, if it's water cooled, that can be a little different. But you're all of a sudden then you're dealing with how are you managing the water for the condensing? Because it's all about how we're condensing that refrigerant.
I could speak just a little bit to some of the sensitivity of the system in terms of the ambient temperature and things like that, where you might want to, like Damon said, consider not putting it inside. When we've had subtle changes in ambient temperature, and this was all sort of as we were out in the chiller, so that the chiller was working a little harder than it should have been at the time. But that discharge of that hot air is so critical, where the difference between the sun being out or versus being in the shade could make a difference. We've had issues with, and again, this is before when we were overworking the chiller a little bit, but high discharge pressures where we had to hose down the condensing coils with water to try to get them cooled. And if you're cooped up inside a building with no real airflow and no options for that kind of stuff, I think you're taking that already sort of delicate balance and I think if your manufacturer is building the system for your hot climate outside, you're probably going to be just fine. But it's a delicate balance there, and I think you're inviting a lot of different issues and sort of the inability to run some quick and dirty solutions in a pinch if you have to, if you're inside a building there.
Yeah, I'll add one more point to the conversation too. It's often I do this to myself oftentimes, so admittedly I try not to forget it, and I like to remind people that we get ahead of ourselves when we think about refrigeration. We think about what we're actually doing. When you're removing the heat from the tank, if you're going to expel it back into the building, really just lowering the efficiency of your process. The best thing you can do is get it as far away from that tank as possible, so it doesn't just end up transferring back through your jacket back into the beer. The easiest place to do that is your biggest heat sink, the outdoors, especially in a warmer climate. I've worked in the first half of my career, I worked with a lot of chillers basically right on the equator, in offshore environments, which are already harsh, and chillers that were designed to operate in 95 to 105 degree Fahrenheit outdoor air temperature perform better in that regard than some chillers I see that are operating in negative 10 degree Fahrenheit. So just make sure that you're buying the right product, and make sure that you're actually transferring the heat to a place that can accept it, because your building probably isn't the best place to accept it.
Yeah, well
this is not a technical point, but also something to consider. We had what should have been a rooftop air conditioning unit or refrigeration unit, not a chiller, but for a cold box, we had mounted on top of the cold box as opposed to putting it on the roof to save money when we opened, 10 years ago. And as soon as we could, we had that thing moved to the roof because it's in our building where our retail space and tasting room is also. So it wasn't necessarily affecting performance. The cold box was staying cold, but man, did it make a racket when people were hanging out, having a beer, trying to talk. That's something else to consider. If you've got a shared sort of production retail space, tasting room that's open to the public, that kind of thing, you're already going to have pumps turning and air compressors kicking on and off. And it's just one more way to sort of minimize that maybe unpleasant experience for your retail customers.
Good, great. Hey, I just wanted to let all the attendees know too that, if you've got questions that you feel you may want to schedule a one-on-one session for, by all means, please go ahead and do that through the vBrewCon website. I myself will be available to field any one-on-one type questions you'd like to cover. But kind of as we were talking, I had a question that came to mind that I think you guys could really share some good insight to. And this is regarding the piping system. If I'm looking at my piping system and I'm trying to make a decision between, let's say, for example, a 2-inch pipe or a 3-inch pipe, do you guys have any input? Should I plan to go bigger, or could that affect me if I don't? What I'm saying, should I spend the extra money and just go bigger, or should I stick to a smaller size pipe diameter?
Well, it's a good question, Damon. I'm sure a lot of people out there are asking themselves the same thing. Maybe even along the lines of just tonnage. Is my cooling capacity big enough? Should I step up to the next size? So when I am ready to grow again, I can do that. Sometimes you gotta take a step back and make sure that the entire system works together. It would essentially, you wouldn't go out and buy a 80 barrel brew house when all you have is 10 barrel fermenters. That really wouldn't make a whole lot of sense. So you got to make sure that that your pumps, the capacity of your pumps, are designed to be the same. If they're variable frequency drive pumps, is that going to affect is the size of the pipe going to affect how those operate? Likewise, if you're oversizing your chiller, is it going to short cycle? Is it just going to come on, run for 35 seconds, and then kick off because it did as much cooling as it could in that time frame? So again, it's a much more, that's a little bit too narrow of a question, and you'd have to be a little bit more broad with some detail. Like we spoke about earlier, you can't have enough detail. You can't have enough information to share with your vendors. But sometimes bigger isn't necessarily an option. Sometimes you're going to end up, you might find yourself in more of a problem than you wanted if you tried to upsize just out of precaution. So make sure that the precaution is based in scientific fact.
I had a few things on that real quick.
Yeah,
just
great.
sort of to Gary's point, one of the things that you'll run into is the actual volume contained in your piping system. I think I have roughly figured out that our 110 millimeter, which is nominally like a 4-inch pipe that we use, it's not quite, but it's pretty damn close to a gallon per linear foot of glycol. So glycol is not free. You're diluting it with water, obviously, but around here, a 55-gallon drum is north of $1,000. So if you got a lot of linear footage of piping, the bigger the pipe, the more glycol you're going to need. That's a cost consideration. Bigger piping is going to be filled with more glycol. It's going to be heavier depending on how you're supporting it from your roof or your ceiling, that kind of stuff. And then the other thing that is an option, a situation where we had a 90 millimeter, about 3+ inch header originally. And when we built the new loop, when we put the new chiller in, Pro had actually advised us to go with a larger pipe out of the chiller until such point as the loop sort of split off and went its separate ways. So when we were supplying X number of tanks and drops and this and that, we actually used a larger diameter pipe. So you can sort of address it after the fact if you have to. We run 4-inch for the first, 100 or 150 linear feet, and then reduce down to 3-inch where that's all we need. So the fittings are all different prices too. A 4-inch elbow is more expensive than a 3-inch elbow and all that stuff. So you sort of can do a mix of both. You don't have to pick one size and run with it, which is probably especially true if you're sort of growing piecemeal, adding things over time and growing, again, not to beat a dead horse, not starting with a blank slate, which, a lot of people are not. Or if you are, it's coming 10 years after you're in business and you get, you're fortunate enough to, as some of these guys have, build a new brewery. But yeah, I mean, you don't have to pick one thing and run with it either. You can sort of address some of those things later on without too much issue.
Oh, that's great. That's great. Well, guys, and everyone, I think we're drawing to the near of the close of our presentation. So if there's, I don't think we have any other questions from the attendees. So just as a wrap up, I just really want to say that I really appreciate the three of you guys jumping on and tackling this with me. It sure means a lot. So I appreciate that.
You're very welcome. Thanks for having us.
Okay. Thanks a lot, everyone. We'll go ahead and end the session, and we will see everybody later.